Page 17, comparing fractions. Got a couple ways that we can do this. Maybe the simplest in most cases is to rewrite the fraction. Sometimes we have to rewrite one or both, or maybe they're, well, it would be pretty silly if they already had a common denominator. So we'll rewrite them with the common denominator. Denominators on both will be the same. And then we compare the numerators, the top numbers. Might be less than, greater than, or equal to. If you have trouble remembering less than, greater than, a trick that I learned is that less than looks kind of like an L. You just turn your head a little bit, you get that that's an L. So that's less than, that's greater than, or alligator eats the bigger number, Pac-Man eats the bigger number, however you want to remember it. And we're just going to compare using inequality signs. So 1/12 and 3/4, well, those don't have the same denominator, but I can get them to have the same denominator. 12 and 4, the least common multiple is the denominator that I want to use. You may be able to look at that and know from a previous class, or you might need to do a little bit of work. 4 goes into both of those. Left with 3 and 1, those are relatively prime. 4 times 3 times 1 is 12. My LCM is 12, so 1/12 stays the same. 3/4, well, I multiplied 4 times 12, I multiplied 4 times 3 to get 12. I'm going to multiply 3 times 3 to get 9. So I'm multiplying by kind of the other number there. So we get 9/12, and 9/12 is a lot bigger than 1/12. Let's do another example. Let's look at number 3, 3/5 and 5/3. Okay, find the denominator I want to use. Well, hey, those are relatively prime, so it's just their product. 15 and 15. If I want, I could write it out like that. So for the first fraction, I got a 5, I need a 3. And for the second fraction, I've got a 3, I need a 5. Multiply this one by 5, top and bottom. Excuse me. Sorry, first one goes to the 3. Times 3, top and bottom. This one times 5, top and bottom. And I get 9/15 and 25/15. Another way to do that is to look at those numbers, 3/5 and 5/3, and make an argument. 3/5, it has to be less than 5/3. Why? Think about it a moment. Feel free to pause. Well, 3/5 is proper, it's less than 1. 5/3 is improper, it's more than 1. This is called using a benchmark number in between. If 3/5 is less than 1 and 5/3 is more than 1, then 3/5 is less than 5/3. So you can make a verbal argument, or you can do the calculations here. And then we have 4 through 6 as well. And I'll tell you there's a similar thing that can be done in number 5. We can make an argument, kind of like the proper-improper distinction, but a little different. Think about that one. As always, you can pause to do it now or do it later. State which of the following are equivalent. Are these equal? Are these equal? Are these equal? Are these equal? Let's look at 10. So 10, are these equal? Well, I could find a common denominator, would be 22. Or I could just say, wait a second, I've got 8 pieces in both cases. The numerator is 8. If I have 8 pieces of a pizza that's divided into 11 pieces, and 8 pieces of a pizza that's divided into 22 pieces, well, assuming the pizzas are the same size, I'm going to, and assuming I'm hungry, I suppose, I'm going to want this 8/11. So these are not the same. If the numerators are the same and the denominators are different, they're not the same. Think about which one's bigger. I'll let you ponder that. And finally, let's look at, are these true? 5/6 is less than 24/30. Well, let's figure it out. Same denominator. My least common multiple is 30. So times 5 times 5, I have 25/30. I'm claiming that's less than 24/30. Well, no, it's not. That's false. Go ahead and do the same for 12 through 14.